Hello everybody, and welcome back to another video on my channel. Today we will be talking about the basics of collisions. So without further ado, let's move on to the video. So there are three types of collisions. Type number 1, elastic collisions. Type number 2, partially inelastic collisions. And type number 3, perfectly inelastic collisions. Now, each of these have different formulas when it comes to calculating momentum before and after. So, let's cover those formulas. But before we cover those formulas, let's understand more about these different types of collisions. Now, remember, by conservation of momentum in all three, momentum is conserved. What varies, though, is kinetic energy. In elastic collisions, kinetic energy is conserved. In partially inelastic collisions, kinetic energy is lost. Could be other things due to heat or something, but this is what a lot of collisions will happen, partially inelastic or perfectly inelastic. But with perfectly inelastic, you will have the maximum amount of kinetic energy that's lost while conserving momentum. Basically, it's losing as much kinetic energy as possible without violating the laws of physics. So, those are the couple different characteristics of these collisions. Now, let's talk about formulas to calculate momentum and velocity before and after. Now, elastic collisions is just the standard conservation of momentum, where you just have the very simple law over here. For perfectly inelastic collisions, the maximum amount of kinetic energy lost while conserving momentum actually comes when the two objects stick together. So you'll have your m1v1 plus your m2v2, but then since the two objects are going to stick together, we're going to have these two over here, the masses combine, and then just have one final velocity. Now, you might have noticed that I skipped the partially inelastic collisions. Well, that's because the formula is very complicated and more advanced. Now, for those of you who want to look into it, you can search up something called the coefficient of restitution. Now, this coefficient of restitution kind of determines how much kinetic energy is lost. Now, if you look at those formulas, you'll realize that if this coefficient is equal to 1, it just condenses to perfectly elastic. And if it's equal to 0, if it's equal to 0, it'll be perfectly inelastic. And the symbol is E. So if E is equal to 1, elastic, 0 is less than E is less than 1, you have just inelastic or partially inelastic, and E is equal to 0 gets you perfectly inelastic. Now, over there, that is also one very, very important concept, the coefficient of restitution. Now, this is also very important for, let's say, because you can even apply the perfectly or some of these collisions in reverse to understand the initial velocities of these two stuff. So that's really about it for this video. I will be covering more examples and stuff in my next couple videos. But besides that, thank you so much for watching. See you in the next one, and bye-bye.